problem for today is 7x minus 6 parentheses 11 minus 2x equal to equal to 10. Solve it out and you should get a value for x. Remember, for this one you need to distribute the negative 6 to both terms inside our parentheses. When you solve it out you should get x equal to 4. Today we're going to be talking about, we're doing 1.6, absolute value equations and inequalities. After today and our next lesson, you'll be able to write and solve equations and inequalities involving absolute value. First, we need to start out with a couple definitions. The first one is absolute value. Absolute value means the distance from 0 on a number line. For example, if we took, and these two straight bars mean absolute value, if we took the absolute value of 4, the distance from 0 is 4. So the absolute value of 4 is 4. If I asked you what the absolute value of negative 4 is, you would also say 4. Just going to put the equal to sign there. Because if you had this on a number line, if you had negative 4, so you had negative 4 here, then we'd have negative 3, negative 2, negative 1, 0. The distance from negative 4 to 0 is 4, so that is the absolute value of it. An extraneous solution is a solution derived from the original equation that is not a solution of the original equation. Like I said before, absolute value is the distance the number is from 0 on the number line. Notice how we have negative k and positive k, and they're both the same distance away from 0, so the absolute value of both those numbers will be the same. Some steps to solve an absolute value equation. An absolute value equation is in the form ax plus b equal to c, where ax plus b are inside our absolute value sign. We first have to write two equations. Notice how the first one, ax plus b equal to c, goes back to our standard form. We just take out the absolute value symbols. And then our second one, ax plus b equals negative c, again, you take exactly what you see, but whatever is on the right-hand side, you make that negative. Step 2, you got to solve each equation, both of these, and then we got to check to make sure when we plug it back in if we get a correct solution. So our first example, x minus 5 equal to 7. Remember, your first step is to solve it out, meaning we have to write two equations. The first one, you just rewrite your original equation without the absolute value, so you have x minus 5 equal to 7. And to solve that out, you got to add 5, so we get x equals 12. And then your second equation, let me change the color here real quick, make it blue. Again, you rewrite what is inside the absolute value, but whatever is on the right-hand side, you make that negative. So we have negative 7. And again, it's a simple one-step equation. You add 5, and we get x equals negative 2. Next, we need to plug it in before we graph it to make sure our answers check out. So we'll first plug 12 back in, meaning we plug it back in for x. So 12 minus 5 is 7, and the absolute value of 7 is equal to 7, so that one's good. So we can plot that on our number line. And then we gotta check negative 2. Negative 2 minus 5 is negative 7. But again, if we take the absolute value of any negative number, we will get the positive of that. So negative 2 also checks out. So we are good. Go ahead and try this example by yourself. Don't forget the simple steps and come back and we'll have the answers for you. For this absolute value equation, you should get x equals 11 and x equals negative 7. Again, x equals 11 and negative 7. And they do both check out. To check for extraneous solutions, it's a one that does not satisfy the original equation. Remember, it is important to check each solution. 9 times out of 10, you'll have an extraneous solution, like the example here, possibly, whenever you have variables on both sides. So, for this one, you still do the same thing. You still need to write out your equations separately. So again, you write your first one.
I found something on the web.
2x plus 12 equals 4x. Solve that out. You subtract your 2x over, we get 12 equals 2x. Then we have to divide by 2, so x equals 6 for our first equation. Our second equation, change the color back. Again, you take what is inside your absolute value, keep that the same, and whatever's on the right-hand side of our absolute value, you make that negative, so we get negative 4x. And then you solve it out. Again, I'm going to subtract over the 2x, so we'll have 12 equals negative 6x. Then we divide by negative 6, and we get x equals negative 2. Okay, then we got to check for our extraneous solutions. So we got to plug 6 and negative 2 back in. So if we plug in 6, we get 2 times 6, which is 12, plus 12, and we get 24. So I'll write that up here to help us. And we also got to plug it in on the right-hand side because we have x over here, and 4 times 6 is also 24. So this one checks out. So x equals 6 is good. Then we got to try negative 2. So plug in negative 2. 2 times negative 2 is negative 4, plus 12, and we get 8. Plug it in over here, we get 4 times negative 2, which is negative 8. Now, before, remember the absolute value is a distance from 0. Distance can never be negative, so x equals negative 2 is not a solution because you can never have an absolute value equaling a negative number. I'd write that down. Again, you cannot have an absolute value that equals a negative number. Go ahead and solve these equations. Pause this, come back, and we'll check your answers. Alright, for the first one, we should get x equals negative 7 and 13. And on the right-hand side, again, notice how you have variables on both sides. Both of the answers still can be correct, which is true for this one, but I would say 9 times out of 10, one of them will not work. So your two solutions are negative 4/3 and 5. Alright, that is it for today. Come in prepared, ready to work on this homework.